Hello everyone, welcome back to my YouTube channel Better Call Paul. My name is Vivek Kaur and in this video we are going to learn about Kubernetes. We are in our DevOps playlist. So in this video we are going to learn about why to learn Kubernetes, what is Kubernetes, when to use Kubernetes, how to use Kubernetes, uh, if we build the application with the help of Kubernetes and without Kubernetes, what are the differences, what is the comparison, and many more things about Kubernetes. We will crystal clear the concept of Kubernetes, exactly what Kubernetes does for us. So, from the beginning of this DevOps playlist, we are solving a problem like the code is running in my laptop, the application is running in my laptop, application is not running in your laptop. The code is running in my laptop, the code is not running in your laptop. This is the main problem DevOps is solving. So step by step, we learn many services. Like first we learn Git, which is used for version controlling. Then we learn Docker. Then we learn AWS. Then we learn Linux. Then we learn Jenkins, which automates the CI/CD pipeline. Now we are learning the Kubernetes. So each service solves different problems. Like what problem Git solves, like it manages the versions of the source code. It stores the source code as a backup. We can move back to previous version of our application. For this, GitHub is very important. What problem Linux is solving? Linux, when we deploy our application to AWS, then to avoid much more cost, we use Linux instead of Windows. What problem Docker is solving? So, for example, if we have to run application with some version for some a particular group of customers and one version for different group of customers. So this problem was solved by, or this feature will be implemented with the help of Docker, because Docker contains all the source code, all the versions of all the libraries of your Python, which is present in your Python package or virtual environment. So version conflicts was the main problem which is solved by Docker. Containers, images, then what problem Ansible is solving? Uh, with the help of with the help of Ansible, you can create, delete, update, read files or files to another laptops. So these controlling, you can control all the laptops. You will be like a system administrator. So this controlling task, this power you will get with the help of Ansible. Then what another services we use? Jenkins. Jenkins, why we use Jenkins? To automate the CI/CD pipeline. Means you don't have to push the code to, means you don't have to go through all the workflow like pushing the code to GitHub, then typing five commands to build the image, then to run the container, then Docker, and then deploy it to AWS. So many commands, you are automating the typing of all the commands with the help of Jenkins. In one Jenkins files, all the commands are there, means all the stages are there, all stages are completed, and your CI/CD will be automated. You're just one single click, means you just push your code and new version will be reflected to the end users. So this CI/CD automation will be done by Jenkins. Then what comes Ansible? Then comes our Kubernetes. Now Kubernetes, what problem Kubernetes is solving? For example, you are running a smaller application, lightweight application, having one or two end users. Then you have only one instance, one Docker image, and it's a simple workflow. But imagine if you are running an application and it is used by 100 million customers. For example, Netflix, Hotstar, whatever it is. So, for example, Hotstar, and there is a match like India versus Australia. Uh, Initially, in the first over, for example, 10 lakh viewers are there who are watching this match, and somehow means on fifth over, after some wickets, for example, Virat Kohli comes to play the cricket match. Then what happens? The number of viewers from 10 lakh they increase to 1 crore, right? Means 10 times the viewers are increasing. So what happens in the back end? uh, 10 times the workload, 10 times the load is increasing on your CPU. CPU can't handle this workload. Imagine it is like only one CPU, only one laptop, rented laptop present on AWS server. Hotstar is the application which is installed in this rented laptop of your AWS, and it is capable of handling 10 lakh queries, right? Means at a time 10 lakh customer can watch. But 1 crore customers, how these people can watch? The CPU storage has capacity like only 10 lakh customers. It is already 100%. How it can go to that? So then the CPU will crash. Means it will hang. In simple language, it will hang, it will not work. Like you will see 503 error, blank screen like that. So what you have to do? You have to run 10 different laptops or 20 different laptops in your AWS server. You have to build 10 different or 20 different laptops. Laptops means servers. Servers means instances. Okay. So 20, for example, let's take an example of 20 instances you have to create on your AWS server. And when Virat Kohli comes, 1 crore customers are watching the match, then the load will be distributed to 20 laptops of AWS, right? So no CPU will crash. Every CPU is having capacity of 10 lakh customers, and 20 laptops are there, so maximum capacity is 2 crores, but 1 crore are watching, so 50% usage will be there of CPU usage, and smoothly everyone is able to watch the match. Once Virat Kohli out, means wicket of Virat Kohli is there, then suddenly the load will be reduced from 1 crore to 10 lakh customers. 90 lakh customers will not watch the match, right? So what happens? We have already created 20 laptops, 20 instances. So we are paying money on the behalf of this 20 laptops on the AWS. So, and this is very costly, very, very costly. So what happens? This Kubernetes comes into picture at that time. Kubernetes will analyze the workload. If there are 20 CPUs and they are having a peak workload, then all should be running. If only one laptop is there which is running and which is having high load, then this will be running, and remaining will be stopped, remaining will be deleted, or remaining will be terminated. So this load balancing, container distribution, container management, container means Docker's container management will be done with the help of Docker. Docker is responsible to run the containers. Docker is responsible to terminate the containers. Docker is responsible to stop multiple containers. So it is like a captain of the ship which is carrying so many containers, right? So it is like a auto scaling of containers. So that is the main importance of Kubernetes. Uh, if I am saying anything wrong, Docker. So Kubernetes is the captain of that ship which is carrying the container. Means Kubernetes has the power to kill that containers, to activate the containers, to run the containers. If any container fails, then it will activate the dead container, and everything will be running smoothly. So It is the main boss of all the containers, all the Docker containers. So it is the boss of Docker, you can say, which manages the containers, right? So let's see. This is all about a theoretical part. Now we will move to the practical part. I will show you the code line by line explanation, and I will run the commands as well. So let's move to another screen. So in Kubernetes, what happens? There is a hierarchy. Like first of all, there are various containers, right? We know the containers. Docker container means one container means one application, you can say. And then comes pod. Pod means it is like it is having one container or more to more two containers are there. On the top of a pod, there is a node. Node means it is like an EC2 instance. It is like a rented laptop. Okay. And on top of node, there is a cluster. Cluster is having a set of nodes. Nodes means EC2 instances. So cluster, node, pod, container. So this is the hierarchy in Kubernetes. Now this is pod.yaml file. So in pod.yaml file, we have two containers right now. So API version is one and kind means this is a pod. Metadata means whatever specifications are there. This is Python demo. So this is the name of our Kubernetes we are creating. So what are the specifications of it? It contains two containers. One is app1 which is having image Python 3.12. This is a Docker image, lightweight image. Okay, and we have to run the command Python C print hello from container one. So this is a simple application, you can say first application, one container. Same second application hello from container two. Okay, now this is just 21 lines of code, and this is pod.yaml file. I will show you how we use Kubernetes. You have to download this Docker desktop first of all, and here you can see Kubernetes. In settings, you have to activate this Kubernetes. You have to enable the Kubernetes. Then you can check the version of Kubernetes. Okay, I will show you now. So this is Kubernetes. We are inside this Kubernetes folder pod.yaml file. First of all, I will check the version of our Kubernetes. We have because we have activated Kubernetes. We have enabled the Kubernetes here. Okay, so you can see client version, customized version, server versions are there. So it is showing the version means our Kubernetes is active now. So we will see now how many nodes are there which are running in Kubernetes. Okay, I will hit enter. Docker desktop is running right now. Okay, so this is the code which is running right now. Now I will run one most important command, kubectl apply -f pod.yaml. So this Kubectl, what is this? So this is just a command which runs the. This is just a command line for Kubernetes. Okay, and now we are running this pod.yaml file. Okay, and the name of this Kubernetes will be Python demo. You will see once I run this line. Okay, I will hit enter. Pod Python demo created. Okay, now I will again run kubectl get pods. Okay. Previously we have run, then we get only one pod. Now now we are getting two pods. Previously we get only one pod. Sorry, only one node. Now we are getting two nodes. Okay. Sorry, this is a node. Means this is a node Docker desktop, and inside this Docker desktop node we are getting one pod. This is Python demo is a pod. Pod is present inside this demo folder. Okay. Now Kubectl logs Python demo -c app1. So we are getting the logs from app1 container. So we will get this output hello from container one because we are running this container indirectly. Okay. So you can see here hello from container one. Similarly, we will check with the logs too. hit enter, you will see hello from container 2. Okay, hello from container 2. So this is very important. With the help of Kubernetes, you are handling two different containers, container 1 as well as container 2. So this is how you are interfering in between the containers. This is the most important power of Kubernetes. Now, Kubectl get all. I will run this command. You will see Python demo crash and ready status is there. Uh, then crash loop back off. I will explain you this crash loop back off. Restarts 30 seconds ago, age is this and all. So this crash loop back off, this is most important thing. Kubernetes main goal is that the application should be running at any condition. The application should not crash at any condition. So previously, before recording this video, I have deleted the container. I have deleted this Kubernetes. I have deleted this pod. So that's why the Kubernetes got confused and try to restart the container because its goal is to run the application at any condition. That's why this crash loop backup word is there, status is there. Now I will delete this pod python demo. Okay, so pod python demo deleted from default namespace. Now I will again run this kubectl get all. You will see no pods are there. You can see here our python demo is not here. Okay, previously it was here. You can see Python demo was here, but right now it is not there. So it is deleted right now. So this is the most important use case. Kubernetes never see the application in a crash state. If it sees some containers are failing, then it recreates another containers. It initialize another containers which are present. It cannot create the container, but it can initialize the sleeping container. It can initialize the stopped containers. It can stop the running containers. So this is the task Kubernetes can do. So now we have also seen the practical use case of Kubernetes, how Kubernetes is useful, what is the goal of Kubernetes. It means if you are using Kubernetes, then it will never see the application dies, see the application crash. It will always run your application. It will manage all the containers. It will initialize the dead containers. It will kill the running containers as per the workload, and you will see a smooth experience like in big applications like Hotstar, Netflix, Amazon Prime, like that. So all these big applications use Kubernetes to run their application at any cost, means at any overload, at any workload. So this is the most important feature we have seen today. Kubernetes plays a most important role in our DevOps in our DevOps services. So if you like my video and if you like my efforts, then please do like, share, and subscribe to my YouTube channel. Till then, we will meet in the next video. Bye bye.